Hello, everyone. Thanks for tuning in.
Hello.
Hi, Radek. Yeah, so we have an interesting topic today, MLMS to MLOps journey. So how do we tackle the problems of scaling machine learning experiments to production? How do we, harness the kind of chaos that usually is connected with implementing ML in organization of different scales? So yeah, let's dig in, I believe. So I think it's time to get started. So let's start with a brief round of introductions. So my name is Jakub Dubowik. I'm leading the data science practice at the Stream. I've been here since the very beginning. And from the inception in 2017, so I've been helping organizations of different scales adapt ML and work on multiple MLOps related problems. And with me is Radek.
Hey, hello. I'm Radek Suwała. I work as a senior data scientist in the stream, solving and solving problems with machine learning models and machine learning approach, boosting business. So I'm very glad to be here with you. Thank you for joining. Thank you for being with us. Stay tuned.
Yeah, thank you. So just a brief round of introduction for our company. So how we are. So we are kind of we're a data analytics company at heart. So we do a lot of data engineering and machine learning implementation for our customers. We've been founded in 2017, and currently we're over 150 consultants on board. And helping customers of different scales become more data-driven, right? With developing end-to-end machine learning on machine learning solutions and data platforms. And what we have today, what do we plan to dig into? So first of all, we'll start with our current our take on what's ML, what are the current challenges of ML that we faced and we encounter as a data consultants. Then we introduce the concept of MLOps pillars that we kind of work internally in DS Stream. How do we structure our work around the MLOps topics? And we'll concentrate on two perspectives that I personally feel most important for a majority of our customers and prospects. It's scaling of ML implementations and observability. So I'll let Radek take us on a journey on kind of why take us on a journey why it is important to also monitor models after release to production, not only during experimentation and development phase. And last but not least, we'll focus on two use cases that we've implemented for our customers over the last year or 2 years, I believe. At any point, just feel free to drop any questions in the chat. We'll try to address them either throughout the presentation or somewhere at the end. We'll have a separate section to take those. Okay, so just to begin with, like, what do we see when we kind of start working with our customers and prospects? Well, I try to think of it it's of course it's not kind of for every customer, but like each customer, and like irrelevant of its scale, like is using small business, just starting with ML, or a kind of more experienced, more developed data science practice, all fall into some traps that we see some patterns emerging. So for me, like in many organizations, data scientists are treated as a kind of lone wolves that work independently in isolated environments on some given topic, like develop new churn model, or solve the regression for our new product, or prepare a recommendation engine for our new service. And they work from A to B, like they have a goal to solve. They work on it, they prepare a presentation and Jupyter notebook, and they're done, right? They have little regard for when the data comes in, or how the data is sourced, or how the model they're working on are going to be applied in production. And this kind of siloed approach of thinking on how to deploy, how to bring value from DML products brings us to the second problem, that we see that a lot of experiments are being run, but frankly not, a very small fraction, and very rarely do we see a successful implementation of the experiment. And because this kind of the problem that I already touched upon, that people are working isolated, they're working on their own machines, usually in Jupyter Notebook. They don't use kind of Git to commit the code. It's very hard for ML engineer or data engineer to then take it, understand it, and apply it in production, or just to replicate the quality of the work that is necessary for a production rollout. We also quite often see that there is a very limited monitoring of deployed models, and it leads to kind of undetected performance degradation or data drift. Also, we see that there are some kind of feedback loops that are not kind of consistent, and the teams lack systematic process of revision, update, and retraining of the models, which leads, of course, to the models becoming stale after a couple of months. And it's also bound to the fact that the team has limited capacity to work on those problems. So, for example, I hear constantly that we can only spend we can do 2 retraining cycles a year for this problem, right? And this should not be the case. It should be kind of constantly monitoring, and it should only be worked on if the performance is degraded as soon as it is detected. And before there is little control on how this process is structured from beginning to the end, there are the governance and compliance, assuring that there are proper standards around the development is hard, right? So whenever there's MRO, so model risk officer in the organization, comes into play and asks for how this model is prepared, how did you get the data? How are you sure that the results are reproducible, that they are representing, they're not biased, or are not introducing any kind of risk of automatic decisioning based on this product? Very hard. It's very common for the organization, for the data scientists, just to say, well, we have little time, and we cannot really provide you any kind of audit information or any traceability of what is being done. So this is another thing. And also, I also see a lot of experiment time spent on kind of setting up infrastructure or just doing a lot of testing. But then after this kind of round of testing, there is no tangible outcome, because the experiments are not tracked, because the time spent and the code that is being run was kind of changed constantly, or it's not tracked anywhere. So these are kind of the things that we observe as external consultants, that we visit our customers, and we try to help at how we can. And this is where the MLOps comes into play. So for me, MLOps is kind of a bridge between the ML development phase and the kind of bringing value in production, right? So it's kind of it's a mix of best practices we are already accustomed to as a data scientist, like working on a model, EDA, training, proper training, retraining, right? And then comes kind of also this other part that is grounded in the software engineering and DevOps practices, that brings in the kind of proper code quality controls, and the monitoring of the tool, the performance observation, right? And there is a redeployment. And it's no surprise that we are using kind of infinity loop here, because those two should be kind of in sync, right? So whenever there is a degradation of the model in production, it should trigger a kind of action on the ML side to redo the training, and possibly, if possible, of course, improve the quality of the model and roll out new version to production. So it's kind of I think of it as a kind of set of processes, set of tools that allows us to bring sustainable and continuous value of the ML that we are putting out there, right, in our company. Okay. So when we work with our customers, we like to structure our work into 6 pillars that I think that can be relatable to some of you, some of the companies. So let me just briefly discuss all those things. So, for example, of course, different pillars are kind of attractive or kind of relevant at different stages of ML adoption in the company. For example, efficient experimentation is for a small starting point for companies when they try to toying with an idea of implementing or adopting ML in their organizations. They're struggling with kind of experimentation, how to collaborate on ML projects, and how to provide the infrastructure and the kind of data fast for new ideas. This is one piece of the solution of the whole kind of problem with MLOps. Then I think the bigger problem is how do we scale? So there are many more companies that already have some experience or have some kind of adoption of ML, but they are struggling when they come to kind of new problems, new markets, or new technologies that they want to support, to integrate ML into. And how do we assure that this kind of transition from experiment to scalable system is easy, reproducible, and kind of not bringing a lot of friction into the equation. Then at certain scale, the training and the kind of performance is becoming a problem. So especially if your company, if you're using a specialized compute modules like TPUs or GPUs, so finding a sweet spot on the vendor that allows you to be flexible and cost efficient at the same time is a challenge. So we also structure a couple of our engagements, helping our customers work with this. Then, if you're running a lot of kind of online scoring models, like credit risk or prediction of some online kind of actions, like in real time, the model deployment is also interesting this topic, because you have a lot of options out there to go with a self-hosting of the online models, or using some state-of-the-art SaaS solution out there, right? And we also try to help and consult, like how do we make an educated and a proper decision, how do we scale this. Then the fifth, also a very important topic, how do we kind of sustain the value once it's in production, once the model is live and kind of changing the business? How do we assure that the value of ML is still sustained after a year, after 2 years, right? So we have to observe, have to put some sensors around the models. And last but not least, and it's especially growing area of our engagement and interest, like how do we make sure that our models like meet the expectation of regulators, right, around AI and models. I speak here about fairness, reliability, ethics, accountability, right? So how do we control the biases in AI model? How do we assess that the model is not harming humans or consumers, right? So this kind of problems we also try to think about it, and how do we solve them for our customers. But today we want to focus on 2 pillars for the sake of time. I think the most crucial and the kind of the gravity of our solutions, mostly for majority of customers, is I think can boil down to pillar number 2 and pillar number 5. So stability of scalability solution, how do we scale and how do we assure the quality in the long run? And if you feel that any of these pillars resonate with your business, just feel free to schedule a call with us, with our experts. We're gonna just direct it to more data engineering or MLOps or kind of data science, strictly data science problems. We can jump on a call and gladly talk about your challenges and your experiences and how we can make it work with MLOps. So just bear in mind that we are here to help you, and we're also very eager to learn like what's out there, right? What's in the market, what we are still not thinking about, what we are not kind of taking into consideration. Okay, a quick pause here before we jump into scalability. Okay, so I'm going to concentrate on the 3 slides, and I try to concise our take on scaling experiments. How do we show that we experiment efficiently and smart to make it work, to make it kind of portable, to make it quickly accessible and successful in production? So I bring this kind of equation to 3 core kind of rules. So for me, it's like consistent machine learning model building, seamless access to feature and the data that we train the models on, and of course making sure that the kind of groundwork, the base foundation, so the code and configuration version control. So let me start with the most crucial, most obvious, for me at least, that whenever you experiment, whenever you take seriously machine learning, you have to invest into proper code and version control, right? So you have to use GitHub, you have to use any other VCS tool out there, and blend in the proper kind of repo structure that kind of is familiar for all of your data scientists, that introduces and embraces all of the kind of code quality, like linting, like PyLint, MyPy, having some pre-commit hooks configured for all your data scientists to use, which allows them and kind of also allows them to automatically embrace that the code that they're writing has to be sufficient quality to be used as is in production, right? So, and to achieve this, we need to have source control, right? So we need a proper CI/CD also embedded in the actions. And so investing time in setting and kind of promoting, advocating across your team that there is no machine learning project kind of, there's no project that you cannot invest in the code quality, because it just pays off in the long run. Even if it's kind of a struggle maybe for them to work in the first two projects, then it will pay off. Of course, the next step is making sure that the experiments that you run are also structured, right? So they are structured in some kind of a pipeline that's easy, compactable, and portable. That's it's kind of this value of this is that it brings kind of symmetry of development and production, right? Because when you see here the upper hand side of this graph, and I'm using here and kind of a template, the architecture drawing from GCP, but you can find just as well in any cloud provider, they being kind of Databricks, AWS, and Azure, very similar drawing when you have a development and production. And to achieve this symmetry and the synergy of approaches, you have to make sure that the experiment you're running is resembling the production as much as possible. And to do this, you have to use a proper kind of building blocks, right, in the pipeline. And then, of course, last but not least, the feature store. I'm going to kind of pause in here for a second. I'm going to come back to this important feature store in a second in a separate slide. So we have experience working with multiple of kind of pipelining tools that are out there. And what I recommend as a kind of data science engineer and MLOps engineer is like work with something that's like fits your stack, right? If you're in GCP, go with Vertex pipelines. If you're in Azure, use the Azure pipelines or Kedro. In GCP also you can use the Kubeflow, whatever you like. Whatever if it's just use the one that you're most familiar with. This really speeds up, the promotion and the kind of transition to production. What is more like we see more and more companies adopting one or more of those companies, especially the huge companies, the huge corporations, usually are multi-cloud and invested in multiple technologies. And we see some value in creating some high-level wrappers on top of those different pipelining solutions. So think about it. If your company is a certain scale, just maybe think of how you can like make use of a one tool, like define once, roll out anywhere, right? Kind of high level wrapper that would map the APIs of all those clouds that you are a customer of. Me personally, of course, the feature also is feature sourcing. Like feature store is quite important because I've been working with this for the last couple of years. I'm experimenting with different technologies, and here are like my takeaways from this. So feature store is a solution it's a must for a proper kind of production level solution rollout, right? And there are a lot of options out there like Feast and Feather being open source, but all of the vendors, all of the AI vendors out of space have their proprietary and available solutions like Databricks, Feature Store, SageMaker. All of the huge cloud vendors are preparing their own. Couple of watch outs. So it's not the only way. You can also rely on kind of good old RDBMS with proper API. If you're just a startup or just thinking of how do we have a seamless access to features, you don't have to really invest in a kind of full-fledged feature store. You can build one on top of, I don't know, BigQuery, for example, in GCP, or even Postgres database. And here, a couple of kind of watch outs from my side. So especially when using these SaaS solutions, be aware of the costs, because especially online scoring. Online is for kind of online like of low latency scoring, so it's just usually in memory databases, and offline is for kind of every hour, every day, every month scoring, right? So offline in bulk scoring. So usually a solution that encompasses both is quite expensive. And if you're just interested in offline, just make an educated guess, check the prices. For example, in AWS, SageMaker Elastic Cache is like 10 times more expensive than the EC2-based Redis. So if you're skilled enough to use it, you can just develop one yourself and save a lot of money there. If you're interested in this topic, we have quite a lot of kind of field experience in deploying and just testing this solution out there. Okay, so in sake of time, I'll just conclude at this, and I'll give the floor to Radek. She's going to take us on the journey to observability.
Yeah, so thank you. So model is deployed and it works in the production. So model observability into production is very crucial, monitoring metrics and its performance. So the model observability is a comprehensive practice ensuring machine learning model perform and behave in a production, and it involves many stages and end-to-end event logging, tracing, and model explainability to diagnose all kinds of issues, facilitating root cause analysis and continuous performance improvement. Next slide, please. So this is our approach, and based on our experience, I'd like to highlight a few areas where the model observability approach is so crucial and important for an enterprise from business perspective. First area is driven by data distribution and all discrepancies between the data our model was trained on and the data spotted by the model in the production. All kinds of missing parts of business or group of customers model didn't see during training, unexpected events, outliers, trend and seasonality never seen or captured by the model can lead to unexpected results. Moreover, the deployed model can perform well at the beginning just after deployment and start deteriorating later over time. The reason for this can be a data or concept drift when features distribution changes over time due to many reasons, like again, trend seasonalities, some changes in business environments, or changing patterns of customer behavior. For example, the training data used to build a fraud detection model a few months ago won't reflect a new type of fraud that has started to occur in the last month. Next area I would like to highlight is in model observability approach is a training serving skew. It refers to the mismatch between the conditions under which a model is trained and the condition under which it works in a production. It consists of, for example, all features model availability when it is served in the production. How it is important shows an example of one financial institution that decided to build an online credit scoring model. They used feature related to customer transactions generally received from third party, but not available at the time of creating predictions due to many reasons, system integration issues or limitations. Next area, and what I would like to enumerate, I'd like to highlight is system performance, where deployed model works. Very often, low latency of model response or facing peak times is extremely important for business results. E-commerce platforms know how system performance is important in serving low latency, real-time product recommendation, especially in peak hours or Black Friday peaks. For the user and how any issues in this matter can impact on the business and the user experience. Next slide, please. And there are many tools or platforms which we can use for model observability. For example, the one is Evidently platform, where we can prepare reports, do tests, and to do some real-time monitoring. It facilitates model debugging, evaluation, and monitoring. We can also conduct some statistical tests for detecting data drift, prepare personalized dashboards, and create automated pipeline testing. Another one I would like to highlight is Arise AI platform, especially designed to detect and troubleshoot machine learning issues in a production. It specializes in tracing models' performance by analyzing data they operate on. Arise AI facilitates the identification of data drift and it impacts on the model. There are many others widely used platforms you can use for model observability that can fit your landscape or meet your requirements, like SageMaker, Neptune, or a combination of Prometheus and Grafana? Okay, over to you. Oh, Kuba, you are muted. We can't hear you.
Okay, sorry guys for this. So just wanted to introduce you to our MLOps use cases. So just a quick peek of two implementations that I want to highlight. So one is for shipping and transportation company that we delivered kind of MLOps aware organization, high code development standards, working in AWS plus Kubernetes, Argo CD, SageMaker. So whenever they can, they do it in-house. Quite a skillful team of engineers. But they were struggling in a couple of pillars that I think helped them kind of debug and enhance. So first of all, the observability pillar that Radek was describing. So they had a lot of online scoring models pertaining to location of different vehicles and their routes and delivery times. And the online scorings were failing frequently in production. So what we identified quickly is that the serving APIs were crashing because of the logging library was not used properly, and it's all boiled down to kind of feature extraction that was used heavily, but we could not kind of analyze this unless we improved the logging. So what our consultants did is improved. So created a new logging library, introduced across the all APIs to allow enhanced logging, and kind of connected these logs to external Datadog monitoring platform that allows for quicker response, better understanding what's happening in the APIs. Another thing that was failing is we kind of somehow bounded and kind of connected on top of this online scoring is like the data processing pipelines for machine learning features were suboptimal. They were taking a quite long time to complete, and they were not fulfilling the SLAs needed for new real-time model scoring that they needed. So what we helped introduce is like we put some optimizations in the database, we removed some constraints, added some indexes, reinvented the data model for the feature serving, and it brought overall like a 40 times kind of saving, 40 time speed up in the calculation of the features, so which kind of I think attributed from hours to minutes. So this was a huge win for kind of performance of the machine learning online scoring models. And also they are using quite advanced kind of deep learning models for training, and they are relying on one vendor. So what we helped them in the distributed training and tuning pillar, we've did an extensive analysis for different vendors and costs of models. We analyzed GCP, AWS, CoreWeave, and other vendors, and came up with a recommendation given their workloads, given their use and flexibility needs of kind of TPUs and memory for their kind of monthly consumption. We came up with an analysis and recommendation that they introduced in their system. So here we're talking with one customer and this problem spanning across 3 different MLOps pillars for us. And we have another example of the company utility provider that are using kind of the use cases focused around smart metering of the utilities. And here the stack is Azure, Databricks, and Azure DevOps for code control. So here I think all of the challenges are around kind of scalability, because they have a nice kind of wide team of data scientists that are experimenting a lot with the data they have, and they have massive amounts of data, metering data that come every seconds, every kind of couple of minutes that are loaded to the system. But there are a couple of things that were not working for them. So one of things that we identified is like doing quite the separation of environments was fuzzy, I would say. So they were overusing a single Databricks workspace for production and dev workloads. So instantly we arrived with some kind of separation strategy for this, like working on the resource group level separation of workspace of Databricks. That seemed to be the best suit for this structure of the company, and we've implemented this. Of course, another pillar, kind of another thing that was problematic is the speed of deployment. So there were a lot of experiments, but very, very little of them were in fact rolled out to production because they were lacking the experimentation, operationalization symmetry, right? They were not put in any pipelines. There were just a bunch of codes put together, and the machine learning engineer or data engineer that was supposed to roll out in production had a really hard time figuring out how to put it back together, like just based on the input Python files that he got. So what we came up with here is like enforcing a very strict kind of Git repo structure, and we ensured the reproducibility of the solution. We suggested the Dockerized Databricks runtimes. And if you're running in Databricks, I strongly recommend you looking into this, because it's a very safe and fast way of burning in the required dependencies of Python inside the Databricks containers. And this allows us for a flat times of spinning up clusters of kind of 5 minutes instead of like 20 minutes, 30 minutes, even with a lot of requirements, if the cluster needs to install all of those from scratch. So Dockerized runtimes and Git were, I think, good kind of practice to put here. And the access of the data to kind of to democratize the access in different environments, to track experiments for a wider team and be able to control the accesses. We came up with a kind of access level structure using Unity Catalog in Databricks. We are logging all of the experiments through the ML flow inside the Unity Catalog. And because we're logging quite a lot of artifacts inside these models and custom loggers. So a kind of Unity Catalog and proper integration with it's a great addition to any machine learning workflow. We also implemented some data quality checks that allow us to flag any problems in advance, and that's I think the kind of the last component of the solution that we put in here for kind of improving the performance of the model, right? At inference time. So let me stop right here, and I think I will leave some time for questions. And if there are any, please do share them in the chat. So if you're interested in any of our experiences of any projects bound to machine learning, or just even tangent on ML, on MLOps, be it like data engineering, even or data platforms, so we're here to help you. So if there are any questions, be sure to paste them here, or just reach out to us on the hello@dsstream.com. We'll be happy to answer.
Oh, we have a question. Okay. So let me read it. Lovely. Among the various features or options mentioned, how do you recommend organization evaluate and select the most suitable one for their needs?
Oh, well, it's interesting. I mean, okay, it's an easy topic and a hard topic at the same time, because if you're in a given cloud, and if you're using certain technology, it's a no-brainer that you should use the feature stores embedded in your technology. I mean, it's the most apparent, I think, in Databricks. So, for example, if you're using Databricks, there's really no point in using any external feature store apart from Databricks. Of course, there are drawbacks, right? Because if you use the Databricks feature store, you can use it only within the Databricks. So it's like a kind of vendor lock-in at the same time. But I would say that even though it's a huge kind of no sign or kind of stop sign for some corporations, for some organization, if you're solely relying on Databricks, that's the best option that there is, right? If you're in GCP, for example, from my perspective, and you want to have an offline store for just the batch processing, I frankly would not recommend going with the Vertex feature store. There's simply not enough value for me to advocate to the business. I would just advocate or suggest you go with, for example, BigQuery. It's just good enough as it is to be a kind of centralized store for features. And if you're not running in any cloud, I mean, I would say you can even build your own in be it a file storage with a proper API, or be it kind of a relational database with some APIs on top of it, that's fulfilled the kind of needs of feature store, because like point in time joins, the data access, the version on the features. There are a couple of kind of interesting or kind of crucial requirements you have to fulfill, but you can do it in many ways. I think it's all boils down to how much time you want to spend, how skilled is your engineering team. Okay, next one.
Kuba, we have another question. What criteria do you use to determine the point at which automated pipelining becomes essential for an organization?
Here I would say there is not, again, there's there's a fuzzy answer to this one, right? Because for some organizations, it's if you're just starting from scratch and you're a kind of greenfield, I would suggest you invest just now. I mean, from the very beginning, right? But that's a very rare case. I would say, from my experience, if you're running more than 4 models a month, right? If you're producing or your throughput of machine learning models over this, the investment is highly effective. I mean, this will pay out greatly in the near future. It's frankly, and even without adopting the pipelines, it's good to think about having everything in Git, everything in code control, plus some pipelining tool for orchestrated experimentation. It's bringing a lot of value.
Yeah, also model observability approach here can be very crucial because how much and when and how much your metrics deteriorate over time. And okay, we have next one. What are the most common roadblocks organizations face from machine learning experimentation to operational machine learning systems?
So this one, I don't know. I think communication is one of the hardest one to crack, because the siloed approach, organization culture, is a problem in many cases, because the data scientists, they have a quite of narrow field of responsibility. They think the data is not us and the production is not us. We just focus on the machine learning part and that's it, right? So bridging this gap between understanding that the value is being brought only after the ML is implemented in your company, only after the process that you feed ML into is changing the organization, bringing some new customers or new value. Only then it's kind of a job done, right? So I would I would abstract from technological obstacles. I would say more kind of communication, bringing everyone together on the same page, that it's everyone's job to and it's not a job done after a kind of presentation of the results of the model. It's kind of a consistent, endless loop, as we've shown, right? So after a month or two, you have to revisit, retrain, check if the value is still there. And I think the change, right? So organizational change is the biggest blocker, I think, in the mindset. I see that, Bartosz, what criteria do you use to determine the point at which automated pipelines? Okay, we've tackled this one, right? Yeah. Okay. So I don't see anything else in the chat. Okay, guys. So, so I know, Radek, any last comments?
No, thank you. Thank you for all. Thank you for participating.
Yeah, it was a pleasure having you, Radek, here. Thanks for this cooperation on this webinar. And it just so I know there will be another webinar coming in January, so please stay tuned for our new announcements. That's what. And I'm just going to leave you with, I think, happy holidays and happy end of year. And let's reconnect next time in the webinar from the stream. Thank you all for tuning in, and see you next time.
Thank you. See you then.
Bye.
Bye-bye.